Hi everyone, myself Shashidhar. Me and my colleague Venkat will give you the talk on high availability. We both are from open source DB, and today we are talking about what is high availability, why we need high availability, and also what is the benefits of high availability. And we'll talk about few things about different tools we use for achieving the high availability, and eventually we'll show you some configurations how to achieve this high availability things. And first of all, what is the need of high availability? So let's say your production goes down. Is it okay to have you time for your DBS to get back on what is the issue and resolve the solution, get it back on? Is it okay? It's not. Definitely, it's not. So you have to have a high availability system in your organizations, like even banking systems, financial systems. They can't tolerate this kind of production issues basically. And why high availability? The main purpose of this high availability system is minimizing the downtime. So there is this concept called 5 nines, 99.99%, which means like organizations can tolerate up to 5 minutes of in a year of downtime. So financial systems, financial institutions, e-commerce websites, basically these kind of systems definitely need always high availability, highly available applications. So these applications cannot be go down. So in that scenarios, our database also need to have high availability systems, and it's not just about the high availability. Let's think about this data integrity also. Like we should data consistency also we need when it comes to the financial systems and bankings. So the continuity has to be there with the data storage. It's and also let's come with the improvements also. Performance also we have to take care of this. This high availability can take care of high availability systems, and recovery point objects and recovery time objects also we need. Let's say some bad queries come into your primary systems, and that system will go down. You can go with the replication things and all. But let's say your whole data center location goes down. What is the plan for your disaster recovery? That is also main thing in high availability concepts, and also the customer experience and the user experience matters for you as an organization. And the benefits. So whenever your primary goes down, your auto failover has to be kick in, and so your standby has to be, become a primary system. That needs to be happen automatic. That's the main agenda of high availability systems. And the scalability. So any select queries, like all the select transactions has to be can be easily transferable, scalable, and with this high availability systems, we can have as many nodes as possible with the standbys. So in this way, we can scale the systems deployment. And performance improvement. So the performance improvement is we can increase the number of connections with the different tools to reduce the load on the database connections. So in this way, we can improve the performance also. And let's say the main aspect is business continuity. The business has to be continue irrespective of what happens in the disaster situations or any volatile situations. And main purpose of all these high availability systems and everything has to be reduce the manual interventions. That is the main work is in high availability systems. And so we will compare some PostgreSQL tools for achieving the high availability. So not every tool is good for all situations. Some tools are good for some situations, some tools are good for some other features. So let's compare a few tools. There are few things, the features we have to consider, like automated failover, load balancing, connection pooling, replication management, and support multiple standbys. Highly available systems definitely need a high number of standby nodes, and the external dependencies is like, is this tool needs any external dependencies or not? That is also our organization can handle this that kind of external another servers, all that we have to take care of that. And Petroni is one of the things that can easily failover systems. It can be achieved with the Petroni, and replication management, standby nodes, and external dependencies. So these external dependencies, what it will do is like state management systems. So our tools can check with the what is distributed state management. So with this we can check the tools can check that which nodes have healthy nodes, and it can easily fail over the system with the switch to the better nodes. So let's come with the PG pool. PG pool is mainly for very good for connection pooling and load balancing, but it's very difficult to maintain this PG pool. And when it comes to rep manager also have a high auto failover, and also has a replication management. Standby nodes also can be happen, but it don't have a fencing system. What I mean by fencing system is like, if the primary goes down, it can switch to standby, and it make it as a primary. But what if the old primary goes up? If it will comes up, it will also become a primary also. It will be going to be difficult for you. So there is some issue with this kind of situation. We can achieve with the different solutions, but again we have to work on more. And HA proxy, it's more of a load balancing. It is nothing but just routing the load into different nodes. And there is an extension for PostgreSQL. This is a PG auto failover, which is also does most of the things, but it has each situation with a single point failover. That's one of the biggest issue with this. And today we are going to give you a demo on high availability. That is how to configure this with our specific tools. So one of our clients needed high availability, so we give that this solution. So in this solution we use some tools like Petroni and HA proxy, etcd. etcd is a distributed cluster management, state management, and the Postgres we use for different nodes. And the PG bouncer is connection pooling. So whenever a new client comes to the database, it needs to be create a new connection. So every time creating these nodes will reduce the performance of the database. So connection pooling, what it will do is like, it will reuse the old connections. That way it will do. And Petroni is it will do the cluster management, and any failover happens, it will take care of the switchover. And my colleague will do the rest of the talk.
Hi all, this is Akhil from Open Source DB. So, thank you Shashi for taking till now. So, as Shashi mentioned, there is one of our banking client. So we have suggested this architecture for them. So coming to the architecture, there are having 5 servers and 3 in the main DC region and 2 are in the DR regions. So out of the 3 servers we are having in the DC region, one we have one server is allocated to the HA proxy proxy, and remaining 2 nodes will be having Postgres on that, along with the Patroni with ECD as a distributed storage, distributed configuration store, and also for that, along with that, they will be having a PG bouncer as a connection pooling there. So most probably the node 1 you can see here. Yeah, sorry. Most probably the node 1 will be node 1 and node 2, and the another node in the DR will be having the similar setup of Postgres and Patroni with ECD and also the PG bouncer. The remaining two nodes, one on the DC and other on the DR, will be having a HA proxy alone. So what happens with this architecture, like when the client is having the read and read write queries and also select queries allowed, so the HA proxy will divide those, and it will redirect the read write queries to the primary node, and the remaining read queries to the standby nodes. So coming to the ECD, it will be having the cluster configurations, like who is the leader and all the stuff. It will be having those. Coming to the Patroni, it will be managing the high availability and which node will be the primary and all the stuff. And here, as Shashi mentioned, the PG bouncer will be having the connection pooling and all stuff. So I hope everyone understands this. So if any doubts on this architecture?
Yeah, this PG bouncer Patroni will be for failover failback. For this PG bouncer.
Sorry, can you please repeat the question?
Patroni we will use for failover failback automatically. This PG bouncer for what purpose means?
It is for a connection pooling. So what it does is, like all the connections, let's say if a HA proxy is having 200 or 300 requests at a time, what it does is it will get these connections to the as a pool, and it will manage from there. So the queries comes to the
is it like that PG pool?
Yeah, it is similar to the PG pool.
Okay.
Yeah. Any other questions?
What's the transaction range we are looking at?
Sir?
What's the transaction range we are looking at?
Here transaction, I think it will be somewhere around 1000, I guess, but I'm not sure of that. And a question.
So basically you are having two data centers, right?
Yeah.
And your primary is on?
My primary will be on the DC.
Okay, so my question is, I mean, just a thought that if we had one more read replica on the main DC, we could have offloaded the workload. Instead of having just two, we could have had three databases. In the main DC itself, have another read replica to offload the read workload and have the DCDR for your failover situation.
But there are some constraints with the client. They are not willing to give another node. So we have suggested this. Even though we are previously we are having a rep manager with the keep LID thing, but they are even not accepting the keep LID things. So that's why we have not given the keep LID for the HA proxy. They have to do a manual shift from the DC to the DR if the HA proxy server goes on a toss. So this is purely based on the client's restrictions and all this. They are so understanding clients, so we need to take that. So, yeah. So these are the tools that we used. So on DC and DR, I will skip this part. So coming to the benefits of this particular Patroni cluster. So first of all, we all know that there will be a minimal downtime, seamless failover and all. Coming to the scalability point, I already mentioned that HA proxy will take care of diverting the read-write traffic to the primary and also the read traffic to the standbys. So and here for the connection handling, we use the PG bouncer, and for the DR setup is for the data, safer side, we are having the DR setup. And the most important thing, and why Patroni differs from the rep manager and all stuff, is like, as Shashi mentioned, there will be no fencing element in the rep manager. So here we can have a zero, no manual intervention is required here. So the node will automatically rejoins the old primary will automatically rejoins the cluster. So Coming to the configurations, how we done. So here I'm not gonna touch the PG bouncer or HA proxy configurations. I'm gonna touch the etcd and the patroni configurations here. So if you look at this configuration, this is the basic configuration. So one, I have given the ECD name as server 1. I'm named it as a server 1, 2, 3 here, and later the data directory for the ECD, etcd, and the peer nodes, peer URLs and the client URLs. So our peer URLs will go on the port 2380 and the client URLs will go on the 2379. These are the default ports that ECD uses. And later, if you see here, I am giving the total number of nodes. I mean, in this case, there are 3. So I am giving the 3 peer URLs to the ECD initial clusters. So, so getting to the ECD, how ECD handles the failover. So after the configuring, if we start the ECD services, you will be able to see all the 3 nodes are, then endpoint status will be like this. So if you see here, we are able to see the true leader, the leader as true for the third server, which is 80.162. So what happens if I stop the current leader? So as you can see, it is a server 3, and if I stop the ECD services there, it will be showing the status as it will shift the leader to another node. So here you can able to see that it is shifted to the 80.160 here. So what if again the third server gets back? So you will be able to see that it will be following the leader here. So this is the basic how basic demo how etcd follows the handles the failover. So coming next to the patroni configuration, this is a single file, but I have split it into 2 photos just to make sure. So here I have given the basic info. After that, I have given the information about the ECD or the clusters in the ECD. Later, the initial bootstrap details, HBA details here, and the Postgres details here, and the data directory, bin directory. If you need to change any of the parameters like shared buffers or max connections, you can also include that in here. So later, I have used this watchdog. What watchdog does is, it will be another utility where you can able to avoid, prevent the split brain scenario as app manager has a witness node like that kind of thing. So once the pattern is configured, you are able to see once the services are start. What patroni does is, for the primary, it will initialize the database and create the database directly if you give any other database. So on the replica side, it will simply do the base backup of the primary. So later, if you can see here, once all the 3 clusters, 3 servers are up and running, you will be able to see the list. So my third server is leader, and remaining 2 will follow that. So now let us do a quick test, like adding a create, whether it is replicating or not. So I have created a simple table using a create table employee here. So automatically it will be getting created on the node 1 as well. So this is a screenshot. So we have got the replication check here. So later, so how does patroni handles this failover, and what is the case of failover? So here, if you see my server 3, which is 80.162 as a leader, what if I stop that? If I stop that, you can see here the server 2, which is 80.161 promoting as a leader here, and also the replica is the status of the third server is showing as stopped. So once the third server is up and running again, the patroni services are up and running again, you are able to see here that the replica status, the third server status is up and running. So here we are not doing any manual intervention that we are doing in the rep manager, like stopping one of the connection pooling, connection pooling stuff and all. So here we do not need any manual intervention.
Here one question.
Yep.
you stop your Patroni services on server 3.
Yes.
Okay.
Right.
And from server 3, you are checking that list also. So that Patroni CTL will work even though service is stopped.
I mean, Patron CTL will be working. It is working. You are able to see that. It will be working.
Okay.
Yeah.
Okay.
So, I mean, Patroni CTL is some. I mean, it's another utility. It will be using. Patroni will be using that. So,
It's not connected with the services.
I mean, it is not connected with the services, Patroni whole services. So, coming to the challenges and considerations with this particular HA architecture, I would like to say, in the initial time, it will be a bit complex than the rep manager. So, that it's a single time we have to take care of that. And coming to the latency, we need to check the latency between the main DCS and DS. If, as one of our friends says, if you are having all the nodes on the DC, it might not be the case. But coming to the consistency part, once any failure happens, you need to be able, I mean, you need to check the data, how consistent it is going and all the things. So here I would like to conclude. So we have these we have explored a couple of tools here, and Patroni with HA proxy and PG bouncer cluster will be there. And if you need any any banking services and all, your production need to be high up and running, you should be have to invest some time or some things on the HA. It must be there. So just go explore the different tools as Shashi mentioned, implement them, and find the best architecture what suits for you. So any questions so far?
There are a couple of questions that you want. They share one question.
Yes, sure. Yeah, please.
In that initial table,
Yeah.
in that initial table, can you just go back to that table?
Patroni YML and ACDC YML, ET, CD YML. Can you show me here?
This one?
This is Patroni YML.
HCD
ET, ECD T YML. Okay, this is it.
So ETCD is your secret
So what kind of codes we need to open among all these three nodes to configuring this Patroni and ETCD?
Are you asking about the ports?
Yeah.
Yeah. Basically, ECD, for ECD you need a 2380 and 2379. For PG bouncer 6432, and for HA proxy I think 5000 or 5001. I mean, and for the Patroni it is 808 8080 I guess. And these are the default ports we will be having here.
So do we have any URL where everything is properly documented? This kind of port need to be one, because in our another technology we have that documentation also. So for this, where we can find out those things.
I mean,
he's asking, is there any community?
So that's
I mean, yeah. We wrote a couple of blogs on the rep manager HA things. If you want to check out, these are the links. And we have started a blog series on Patroni itself. So first blog is out, and remaining blogs will be coming in the couple of weeks. So if you can visit those, they will be available in our OSDB website. You can check it out there.
So this Patroni, when we are going to set up, so all my three nodes are individual EDB Postgres servers, or we have to set up logical or streaming replication then on top of that Patroni and ACDC. How
I mean,
that?
I mean, it will be. I mean, The Patroni will does the PG base backup of the what you call the leader, right? So there will be a replication inbuilt. So if you want an extra thing, you can do that.
So I need to first install the individual EDB on all 3 nodes.
Yeah, you have to install your Postgres, but do not initialize the database, but you need to install the Postgres. I mean, the two community
All
Postgres.
3 nodes.
Yep.
And then later on, what we need to do is
You need to install the ECD, Patroni, and also Watchdog. Later, what Patroni does is, for the primary, it will initialize the database and it will create the data directory. If you see here, I have changed the data directory here, so it will create that one. And later, for the replicas, it will simply take the PG base backup of the primary there. The streaming will happen.
Means this Patroni will take care of those things.
Yeah.
Once we will set up the Patroni.
Yes.
So Patroni will take my leader base backup and will restore on
Replicas.
First replica and another second
Yes.
replica. Like, so
All
I
in-
don't want to make any changes in the configuration or anywhere. Means
There are a couple of changes for the each node. You need to change the URL, like IP addresses and all stuff. You need to change that. Each node will have their set of IP address, right? You need to change that here, and in ECD you need to change that here. So those basic changes will be there in the configurations. You need to do that.
do you have any recorded video session to set up this 3 node Patroni cluster? Because we tried in our environment, it was not succeeded. So Kashi said we'll give the document and then try it. Like,
you can wait till our next blogs will come, or not. You can consult us. We will be happy to help you.
okay.
By using the one OSD, open source database,
Yeah.
Okay.
can we the one to health checkup also can be used? And what about the health checkups can we do? Like a BP and pulse rate, heart rate, and heartbeat.
Okay, we'll get back
What
to
are
you.
the one, the
Sure.
different types of
Sure.
the health can be checked by using the one OSDB, open source database in the one PostgreSQL.
Our company name is Open Source DB. We do a Postgres stuff. You can do the BP checks and all on for the database, Postgres database. You can. OSDB is not a tool, sir. It's a company name. So we will serve the Postgres in and out. So for database, we can check the BPs and all stuff. Not regarding the human check, but it's regarding the database check. We will do that if you need. So, any other question? Yes, sir, please.
Can you just go to the previous slide where you're comparing all the,
To the create table, right?
where they're comparing all the tools. So yeah, so here in each of these, right, you have some feature which is missing in the other, right? So just this thing, have you used multiple tools where let's say load balancing is not available in Patroni and you're using something else to do load balancing? Have you used such a setup?
The current setup you have seen this. I have worked on this. I was been working on this since last 2 months. And coming to another tools, I have worked on the rep manager and with the keep LID architecture. So what it does is I will be having a Postgres on a node and a rep manager on there. But for that we need I worked one primary, 2 standby and a witness node with the keep LID services to manage the VIP there. So I worked on that architecture as well.
I'm wondering if you have, anybody has worked on combination like PG pool and Patroni, where PG pool you're using it for the load balancing and Patroni as a failover.
Great presentation, Sashi and Akhil. So I'll summarize some of the questions that we have. The business standpoint of the question, what Santosh had put up is really cool, right? If I give my cluster and say these are the nodes, right? The 3 or 4 nodes that are part and parcel of my HA cluster, what are the gaps, right? How do I make sure the architecture, the tool set, the whole of the ecosystem that we have built has got any gap? I don't know, do we have any scope for improvement? As of now, we do not have any, but building one to find out what are the gaps with the tool set that we have chosen should not be a big deal, right? And then one gentleman had a question about how many transactions have you done with this. So on a very, very high level, right, the customer is a Middle East banking customer. We were dealing with them like 1200 to 1500 transactions per second. That's one question that I wanted to have an answer. Ritesh, to your point, like Hari mentioned, all of these tools have got different permutations and combinations. You will have to choose what is best for your customer, right? So you can work with Patroni plus PG Pool, right? Nothing stops you, right? PG Pool has got its own clustering underneath, right? It has got its own load balancing underneath. If you would like to pick and choose PG Pool plus Patroni, yeah, nobody stops you, right? PG Pool plus there are other tools like Zalando, which is another close to source, but a really cool software from an HA standpoint, right? So the combination is important with respect to what your customer would like to do, right? There was one other question that I and Abbas were discussing. What happens if Patroni on one of the node goes down, one of the data center, or the entire data center goes down, right? It's not something that we don't do, we don't see, right? There are possibilities, right? Software has bugs. Your data centers have got their own gaps, right? If the entire data center goes down, your business continuity plan on the DR system should be able to make sure your application is connected, your HA proxy is connected, your entire connection concentration is connected, right? That's why you maybe summarize the whole questions. Now, if there are any more questions, I'll be happy to answer them. Sir, to your question, right now, if we are talking about health checks, RepMGR has got its own monitoring system per se, right? You will have a schema called as monitoring, which pumps in all of the replication, all of the heartbeat checks. Similarly, on Patroni also you have bunch of tables which keeps track of what is my replication like, how much is the heartbeat check that I am sending across. And then there are parameters within the Patroni YAML file which says, hey, how many number of seconds should I be waiting before I do the election of another leader, right? There could be a network blip, there could be a latency between your DR data center and the main data center, right? If you would like to identify whether that is a network blip or a resource contention or for that matter anything, so those are some of the parameters you would like to tune, which will tell you what is your heartbeat check, acknowledgements and so on and so forth, right? But from a whole clusters health standpoint, I don't know if we have tools, we will have to rely on monitoring systems. Obviously, Prometheus plus Grafana is a good hard tool set to start with to monitoring the health. I hope that answers most of the questions that we have had. If there are any more, I and Sashi and Akhil will be happy to answer.